It's full screen right now, isn't
Yeah,
it?
now it's perfect.
Okay, so sorry because I was at you were watching the presentation. This was the first slide. Second with the recommendations, and the third one is the agenda. I'm going to do a very quick introduction about the in-transit project. Later, our colleague guy is PhD in the Julban Research and Technology Institute, and he's going to introduce Industry 5.0 and will show us several projects that they have it. Also, CATEC, the Aerospace Technology Center of Spain, that is here in Seville, with very close to CTA, will also present their innovations project related with this topic. And at the end, I will give a very, very briefly conclusions about the event. Okay, so go ahead with the presentation. This is the information of in-transit. I think that you know it really well. This is the general objective of the project. I am not going to in deep, but our objective is to generate new value chains between interesting sector in Europe. This is aerospace, construction, additive, advanced manufacturing, and textile. Okay. So we have a concept. We are helping the SMEs to be more resilient, following the different steps. We have several different kind of vouchers to support you. We have incubate action, innovate actions. So some you are in this bonus because you were beneficiary of the innovate. Okay, but we have more activities to develop that will be that where you will be able to receive some funding to develop small projects, and of course the scale up and the dissemination of your results through Europe. This is the overall information of the project. I don't want to be so specific because I know that you have seen this presentation. This was the Innovate activities. Of course, we are working on one of the topics that we designed, and of course, in the first course was open, but it was mandatory to select different services. And I think that in the second one, you will have the opportunity to repeat those one the different services that you have. It's only a reminder. We also would like to remind you that we have two upcoming learning expeditions, Seville and Slovenia. So if you are interested, I don't know if it's open, the Slovenia one. Seville was nearly closed, but I hope your participation in this learning expedition that's quite interesting to have the information of the industrial ecosystem in the area. And those are the estimation of the calls. And I have to say that we are expecting to open the first developed voucher in January 2022, and we hope many projects from your side. Okay, so I think that's all. This is the overall funding that we have for all of you. I think that's all. You can see that we have a lot of partners helping you, and today we have the participation of Jules Burns. And I think that it's the time for Guy. Guy, please, can you share this presentation? Guy Cavanaugh from the Institute Jules Verne, please, Guy.
Yes. Is it okay for the sharing? Or?
Yes, no, I cannot see your presentation now. Can you share it again? Okay, now and
now it's okay.
Now it's okay. So the floor is yours.
Okay. So I will present Industry 5.0. I am in charge of technology transfer at Research Institute Jules Verne in Nantes, in west of France. And I have an experience in robotics and in a real world of innovation and industrialization of projects in different field, in industry, logistics, building, medicine, and so on. So the objective of this presentation is to give you a practical view of Industry 5.0 with project through this presentation with a concrete example. So I have divided this presentation into three main parts. The first part will be a description, a quick description of the concept of Industry 5.0. And in this part, I will describe the difference between 4.0 and 5.0. After that, I will describe our institute and different activities in the field of Industry 5.0 in our institute, in the field of IT or new processes and robotics, cobotics. And the three parts of this presentation will be the important part in which I will describe 8 real projects, 4 in research and 4 in technical services in the field of robotics welding, positioning, robots in the plane, manufacturing, flexible system and monitoring system. And in a second part with example in the field of healthcare, in the field of nuclear, in the field of logistics, and in the domain of the painting. So the first part is the description of Industry 5.0 and 4.0. So as you can see, the description of Industry 4.0 is an adoption of set of technologies in the field of industry and production in order to enhance the quality of the product. So we have different fields. You can see autonomous robots, augmented reality, the cloud, cybersecurity, industrial of things, and so on. And this is the source of Boston Consulting Group. And when you develop the concept of Industry 5.0, based on this first description of Industry 4.0, we develop a new approach with a more holistic approach in which we integrate the collaboration between human and machine and harmonious coexistence between automation and human labor. And the other point in this new concept of industry, the fact that we use the environment impact in the studies and techno-economic approach of the project. And other point, very important, is that in Industry 5.0, we try to create a working environment where humans and robots can work together. You will see in a different example this concept. And the key element on this Industry 5.0 is first human-machine collaboration, customized production. In Industry 5.0, we try to produce goods in a more personalized way to meet specific customer needs. And we adapt the production with the constraint of flexibility on the production line, for example. The fourth part is environment and sustainability. And we try to minimize environmental impact by using, for example, cleaner technology or optimizing production processes. And the last point, key element of this industry is the development of human skills in order to enhance the quality of the system by the automation, the global system, industrial system. Okay? So the second part of this presentation is the description of our institute, Jules Verne Institute. It's an overview in which I will describe the different activities of our institute and describe the fact that we are in the core of this industry 5.0. So the main activity of our institute is industrial and collaborative research center dedicated to the manufacturing. And we have two offers. The first one is a technological research in open innovation with the French project, with European project, or contract of research. And the second offer is technology transfer with the sales of patent and license and pre-industrialization project with industrial partners. You can see the mission, the vocation of our institute is reinforce competitiveness in the French and European industry. And the mission is to accelerate innovation and promote technology transfer to the factory. And the core of our activity is collaborative research. You can see the strategic positioning in which our approach is oriented solution, synergy between manufacturer or integrator and cross-fertilization between sectors. You will see an example, for example, in the medical field, we can slide some technologies from industry to medical. This is an example of activity in our institute. You can see the strategic domain, integrated product process design, innovative processes, and smart flexible system, and our assets with industrial skills, industrial platform, and financial lever for this for our institute. In this slide, you can see the different project, European project, around 20 project, research contract, and very important point, the people in our institute, around 140 people now, and an activity of 25 million euro. You can see the different partners, the field of aeronautics with Airbus or Liebherr, in automotive with Faurecia, Peugeot, Renault, in the naval application with Chantier de l'Atlantique, in energy with EDF, and so on, and partner in the field of research, European research. And very important point is the ecosystem of SMEs around our institute in order to creation of added value in the small SMEs in the field of renewable activity, in the field of robotics or mechanical application. On this slide, you can see the core of our activity in Industry 5.0 with the mobility in industrial environment, manufacturing flexibility, forming and preforming process, assembly and joining, and digital manufacturing with the digital twin, advanced data processing, and artificial intelligence in this part of activity of digital manufacturing. And these thematics address industrial challenges. In order to develop the project, we have 5 teams in composite, metal additive, monitoring control, robotics, and modelization and simulation, around 100 people in research in our institute. And each team work with key equipment, for example, robots in composite application, robots in the welding. You can see mobile robots here, or software in order to simulate some processes. The main process in our institute is the technology maturation path from industrial needs to factory. And in this part, we involve integrators. We integrate use case of project and technical economic approach assessment for each project. You can see the partnership with a cluster EMC2 in order to address ecosystem of SMEs. And you can see the different European project in which our institute is involved. For example, suspense in coordination and different other projects in robotics, in different field of application, in new process development. So after this short introduction in 10 minutes, I will present a real project in our institute, 2 minutes per project, in order to have a global view of this industry 5.0 in the real world. So the first example is an example in the field of weld assembly solution for flat panel. And in this project, you can see the robot just here. And we try to develop a system in order to enhance the quality of welding and to adapt this kind of robots in a real industrial environment in which there is human and machine collaboration. The impact of this kind of project is the control of the weight of the robots, the reduction of the production cycle in order to enhance the performance of the end user, and the reduction of hardness of welding operation. You can see the partners of this project, and if you want, in this link, you can see a video of the detail of the project. So you see that in this project, we helping people build ships with robotics welding. The size of this project, the budget is around 4 million euro. You can see an environment in which welding robots working in coactivity with workers, as you can see on this picture. You can see the parts of Industry 5.0 with the digital tools associated with the welding robots. You see, this is the description of 4 robots with a supervision system in order to create a global welding production. And very important point is that in this robot, we involve an SMEs. The name is Europe Technology with, I don't know, perhaps 500 people. And these partners will propose the complete solution of robotics to the end users, different end users, this one and other end user. This is the first example. This is the first example in the field of shipbuilding and welding with robots. The second example is an example in the field of handling and positioning of heavy parts for assembly. In this project, the main axis of Industry 5.0 is the customized and flexible production. In this project, we develop a concept of aerostructure assembly line, which is flexible regarding product variant and product rate evolution. And the system consists of positioners. Positioner, it's a parallel robots mounted on AGVs, automated guided vehicle, and controlled by a complete system in order to have a servoing with a visual system in order to position the different parts of the plane. In this kind of project, the impact are flexibility of production, reduction of cost in order to have a more efficient system, and enhance the reconfigurability of the workshop of Airbus company. You can see the partners of this project, and AC System, for example, is an SME in the field of automatic and studies in mathematics, and different other partners. You can see a description of this project with the the aim of the project, helping people with playing with robotics. You can see here the digital model of the visual servoing and the real visual servoing with the assembly of the different parts. And here there is the robots, and you can see a robot with 4 parallel robots integrated in a global solution. And this solution is proposed by an SME. The name is CTR with 100 people. And in this project, we have some action with this SME in order to facilitate the integration of the solution in Airbus factory near Nantes. This is the second example in the plane with the positioning robots. The third example is a global system in which we associate different bricks. The first is robotics with arm and AGVs. The second one is sensors with different sensor, visual sensor, with camera, profilometry sensor, and so on. You can see the different sensor. Target in order to position the system, and measurement system. And you can see the parts just here. And in this project, the aim is the flexible and automated non-destructive control platform for the manufacturing processes. And in this project, the aim is the automation of non-destructive control, for example, to control the material health, visual inspection, and geometry inspection. And another part, very important part of this project, is the analysis of the data from the different sensors in order to take decision in terms of quality of the product, for example. You can see the partners of the project. Another project in the fourth project in the same area is this project of monitoring of composites by infusion for the naval activity in order to build a submarine. And in this project, it's very interesting project because it's human project in which we need to reduce the mental workload with a decision support tool. And the objective of the project is establish a methodology for the first time compliant for the large dimension composite parts with in infusion process in composite, detect anomalies in real time, and develop a decision tools for the pilot operator of the process of infusion. And after that, in this project, there are some activity in order to facilitate the transfer of the results of the project to the factory. And in this project, the impact is first human impact in which we want to reduce the mental workload. We want to reduce the cost of the product production and environmental footprint. You can see the partners, and on this link, you can have some details of this project. So some pictures, you can see the monitoring of the composite infusion composite just here with the sensor here. You can see a variety of sensors, different sensor with a conditioner block just here. You can see the structural health monitoring with measurement just here with a camera just here. And 2 examples of monitoring of fiber placement with a laser profilometry, with a thermography system. And very important point in this project of Industry 5.0 is the data analysis in real time to give some information in order to take decision in terms of process control. This is the first part of the description of the project. These four projects was project in the field of research, applied research. Now we will see four other projects integrated in industrial application. The first one is a project not in industry 5.0, but in healthcare 5.0. And in this project, we assist surgeons in their surgical operation thanks to an imaging cobot. You see just here an operation room. You can see the mobile robots. You can see the surgeon. And in this project, our institute worked on different axes of enhance of this project. The aim is the improvement of these cobots. You see the mobile robots just here. You see the laser guidance. You see the tool just here with a sender of X-ray system, receiver. You see the patient. You see the surgeon. You see the interface with the imaging system. And for this project, the clients, GE Healthcare, want to improve this system. So we started with modeling and simulation and proposed a new medical device design in order to change the link here between the mobile robots and the tools in order to have more efficient planification of movement of the robots. After that, we developed a new structure of the product in order to lighter the medical device thanks to the use of composites. And with the use of composites, we can integrate in the project some functionality, for example, for the protection from X-ray with the machine. And other very interesting point is that in this project, we integrated global view of technico-economic approach with the cost of material, cost of process, and performance in terms of image quality criteria. So this is an example in the medical field. And in this project, you can see the global approach of the project with the integration of surgeon and patient in the surgical room. The second industrial example is an example in the field of nuclear repair system using with the robots. And you can see the shape of the nuclear piece, just here, the nuclear parts with the specific shape. You can see the visual control system, the perception system. It's an hybrid system with a laser beam and camera. And you can see the robots just here, the Yaskawa robot. And in this project, the aim is the reconstruction and trajectory generation in the complex environment of robots in order to have an hybrid construction. In this kind of project, there is a part of the project in the welding, modeling, and optimization. As you can see, this is not the same part here that this one. And in this project, we use an hybrid process with robotic welding. You see my pointer just here, and 3D additive process here. Okay. In this project, we integrate additive welding manufacturing system with the monitoring of the welding. And in this project, it's interesting project because there is no interaction between human and robot in this kind of project because it's a nuclear application, but there are a lot of interaction and combination between robots and robots. For example, on this picture, you can see first robot for assembly, this one, and second robot for the welding. And there is another robot in order to check, to control, to monitor the welding, the quality of the welding. This is the second example of Industry 5.0 in energy application. The next project is not a project in the field of industry. It's a project in logistics. Logistic 5.0 in order to improve the quality of prepared orders with using of mobile robots and mobile cobots. And in this project, we transfer knowledge and skills in mechatronic and robotics programming, as you can see on this slide. And the very important point is that it's a classic robotics project with a supervision system in order to manage the traffic, to manage the logistic priority, and so on. We help the SMEs, the name is eCobot, to adapt mechatronism architecture of the system with supervision, with interface, with mobile robots, as you can see. And this company have some skills in design. And in this project, there is a specific tools in order to manage interaction between man and machine and the definition of the flows of different pallets or box in the area. So this is an example of project of mobile cobotics in which there are a lot of interaction and the dedicated simulation tools in order to facilitate this interaction. And the last example of a project is of Industry 5.0 is a project in order to make work easier for operators with a retractable cable robots for manual or automatic painting. You can see a video of this system on our site, website. You can see here the painting system and mobility with the robots. It's a cable robots. You can see the real description of the system. And with this kind of parallel cable robots, we can use a solution with painting, automatic painting or manual painting. And in terms of Industry 5.0, when we propose this kind of solution, we define the different interaction between human and machine. We design the mechanical and the mechanical design, and we size the robots with a dedicated tool. And we integrate human interface in which we have a lot of activity around acceptability of the system, integration and ergonomy. And as you can see, there is a specific controller in order to manage the safety chain of the system when we work together with human and with the robots painting. And the last point is that we have some configuration, modelization, and IT tools to manage this kind of solution in robots parallel with a cable. So this is the end of the presentation of this real apply project in this webinar. So to conclude, in this presentation, you can see industrial an R&D project in advanced technologies with a metal and composite and manufacturing activity, with control and monitoring, IT supervision in the different field of application, aeronautics, shipbuilding, naval, logistic, energy, medical. So you see that Industry 5.0, it's not only in industry, it's a global approach with advanced technology, IT in different fields of application. And you can see the global and human approach with interaction between people and machine, and the involvement, it's very important in transit project, the involvement of SMEs in order to propose technologies, in order to integrate technologies, or to develop new solutions in partnership with groups. Thank you for your attention.
Thank you very much, Guy. Very inspiring your presentation. And now is the turn of Eduardo Ferreras. Eduardo is head of the robotics areas in the Aerospace Technology Center, CATEC. So, Eduardo, the floor is yours. Eduardo, okay, it's full screen now. Perfect.
Eduardo, you are muted.
Okay, now.
Thank you.
So, yes, first of all, let's start a little bit about myself. So, as Silvia said, I'm the head of the automation and robotic unit here at CATEC. I'm a telecommunications engineer, but I have been working in robotics and in research and development since more than 10 years, and I'm co-author of 12 international peer-reviewed publications. Mainly right now, what I'm doing is I'm a project portfolio manager. I'm managing projects related to aerospace, railroad, infrastructure, health, agriculture, and so on and so forth. Taking in fields like Industry 5.0, artificial intelligence, deep learning, human in factories. And the idea of this presentation is to inspire you with some of the projects that we have here at CATEC, and also to present a little bit our research center. So I'm going to start with the research center. We are speaking about CATEC. It's Center for the Advanced Aerospace Technology. It's a research center located in Spain. Our main facility is located in Sevilla, in South Spain, and we are devoted to develop of technological knowledge and technology transfer. What we do is we try to take concepts that are generated directly at the university or some research centers, and we try to mature this technology in order to make them reachable, accessible, and appealing to the general industry. Originally, we were created by and for the aerospace industry, but nowadays we have been working with many different areas. And if we speak about these areas, we're speaking about aeronautics, space, as I said, but also software, manufacture, energy, defense, healthcare, agriculture, naval, and logistics. We are nowadays more than 100 professionals, more than 100 customers, 5 facilities around Spain, and more than 200 research and development projects between the ones that we have Horizon 2020, Interreg, ESA, Clean Sky, and of course, national calls like the ones related to the CBT. We are divided in 2 areas of expertise. The first area it's related to avionics and systems, and it's also subdivided in 5 different units. And those units are mainly devoted to the creation of drones. We're proud to say that we are capable of do drones on the way that we like, meaning that we perform the drone from scratch, we design the drone, and we are capable of making with the drone whatever we want, including adding some intelligence on the drones and make them fly by themselves and so on and so forth. The other area of of CATEC, it's related to material and processes, that it's also subdivided in 3 different units. The one related to additive manufacturing, that it's a unit related to the creation and the performance and the research directly related to additive, so printing or 3D printing pieces in metal. We are pretty successful on that field. We have been sending several pieces to the outer space in the last couple of years. The advanced and testing processes, as you can imagine, since we were originally created by and for the aerospace sector, we have been working directly in all the techniques for destructive and non-destructive inspections. And nowadays we are pretty good at, for example, thermographics, X-ray computer tomography, and so on and so forth. And the unit that I'm representing, the one of automation and robotics, that by itself, it's also subdivided in two areas. The one that it's mainly related to the creation of advanced end effectors, and the one devoted to the tools of the operator 5.0, that it's more of a focus of this speak. So, as my colleague before said, Industry 5.0, it's rising, it's one trend, and it's actually sustained by three different pillars. Resilience, we want to make our industry as resilient as possible. Sustainability, we want to be as green as possible. We want to still produce, but make the things on another way. And the one that I'm gonna focus a little bit on this part of the speech, that is the human-centric approach. The human-centric approach, it's an approach that is not novel, but it took more relevance on the last couple of years with the rise of the Industry 5.0. And this is because at some point, we realize that there are humans in our factories, and we cannot just ignore those humans. And humans and human processes are usually related to errors, but they are extremely useful. We are not just speaking about productivity, about how cheap or how expensive it's to have a human there. It's that there are some tasks that it's either impossible or they are extremely expensive to be replaced by a robot. And this is why we have to still have humans on the industries. And therefore, we have to think on those humans. And if we are thinking on those humans, we have to make the lives of those humans easier. To do so, what we do on CATEC, it's to follow the cognitive approach. So we take all the field of the artificial intelligence, the field mainly of the deep learning, and we try to use this technology in order to acquire the knowledge that it's required to perform the task, and also to understand what the humans are doing. So we're speaking about, for example, the deep neural networks that you are seeing right now. This is a project that we did with people from England that was related to discovering road defects directly just using a camera on the mirror of the car. And as you can see, it's just a computer sitting in front of a screen, understanding what is happening. And this is somehow one of the bases of the things that I'm going to present you today, because if we can make a machine understand what's happening, we can go further and really understand something that is happening, for example, in our industry. So as you can see right now, our machine, what is understanding, it's where are the humans? What are the humans wearing? Are the humans wearing PPEs? Are the humans requiring help? Or are the humans having some troubles while performing their work? So for example, as you can see right now on the video, you see one of the human falling. Maybe, well, right now on this video, nothing happened, but maybe it's something that could happen to a human, and maybe this human, it's somewhat that it's right now standing alone on the system, so on the industry. So it could happen something bad for this human if nobody's watching. So we can make, for example, the computers watch and understand if something is happening. Or, for example, this work that it's related to the real human-robot collaboration. So cobots those kind of small robots that you can see on the screen are robots that are meant to work around humans, but and even though they are extremely popular since several years ago, the problem is that industry are nowadays just using them just to not having to have those robots on a jail or to have those robots on a safety way. But the system that we are presenting right now, it's the second approach of collaborativeness, that is the sequential collaborative work. That it's you as human perform the works that it's useful for your production, but then you leave your robot, your collaborative robot, to do the parts that are completely repetitive. And the system is meant to not only do what the human says, but also to understand the human voice, to understand what the human is leaving the pieces where the robot has to work with, and so on and so forth. Everything completely collaborative and in a way that the human and the robot are really collaborating. More projects that I want to highlight. This one, it's just related to smart logistics. So as you can imagine, in our factories, we are wasting a lot of time transporting goods, transporting materials, and transporting tools from one side to another. And this is something that could be directly delegated to other kind of robots, like round robots, like the one that my colleague before already presented, or like the one that I'm showing. And if those robots, like the one that I'm presenting, are smart enough, they can also understand where the humans are, avoid those humans, and try to reach their destination using their best possible available path, even though there are sometimes doors that are closed, and so on and so forth. Actually, those robots are also robots that we are using to perform reconstruction of buildings. The video that you are seeing right now, it's part of a project called Celia. And in this project, something that we are doing is to focus on the building of large 3D mappings directly with those kind of robots. And this is something that we are using to help society, and we are focusing on industry, energy, transport, health. Probably you can now see, or at least recognize a little bit, our robotic cell. If you use a little bit your imagination, you can see a couple of anthropomorphic robots there, and you can see all the walls that are surrounding those robots. And on the left bottom corner, you can see the reconstruction of all our facilities directly with a 3D map. But also we are doing that not only with point cloud, but also with photogrammetry. If you see the two pictures on the bottom, the one on the left, it's a real picture of a real installation. And the one on the right, it's a three-dimensional picture-by-picture reconstruction, photogrammetry, of the system. And as you can see, to perform, for example, digital twins, or to have something extremely realistic on a digital way, this is useful. More things that you can do with your maps. For example, something that we have here inside of our facilities, we have 2,000 square meters of facilities to reproduce what will be an industrial environment. We have some ultra-wideband system in order to perform tracking of persons, goods, and so on, in order to make the industry more resilient. Moreover, something that you can also do with those maps, it's generate your own digital twins. And something that we are working with, it's with the concept of having this digital twin to support the idea of a remote telepresence and to show to some remote users what they have to do. As you can see on the picture, the engineer was drawing a couple of things directly on the air. And once she drove those arrows and so on, the real robot that acts as an avatar in the real environment really represents what the engineer wants to represent. Or, for example, this smart workbench. This system was created in order to fulfill one of the problems that one aerospace company that it's here around that was Aerotechnic. The problem of Aerotechnic is that they are dealing daily with 30,000 different pieces. In your workbench, something that happens when you are the worker is that sometimes you are required to just pack a piece, but you don't really know if the piece that you are packing, it's actually the one that you should be packing. And we are speaking about 30,000 different pieces, and that some days, some of those pieces happens to be purchased just extremely rarely. You're speaking about something like once a year or twice a year. You are not really sure if the thing that you are packing, it's the thing that you should be packing. So this is a way to help the human with the artificial intelligence and with the deep learning in order to recognize what it's doing and to avoid errors that sometimes is not even a problem of the human, but that could be solved with the human artificial intelligence approach. This project that I present here, it's a little bit more different. My colleague already presented a couple of projects related to healthcare. This one it's also related to healthcare, and it's actually a project where we are creating a haptic device in order to train surgeons before performing the surgery. The idea, the concept is that before having a surgery, you enter on a specific device and they perform a 3D mapping of our skeleton. And then with the system, the device that we are creating, the surgeon using a table, a normal table, and the device can simulate and can have the feelings and the sensations that he will have once he will be performing the operation inside of our brain or so on and so forth. Then, just to conclude, other projects that are more related to resilience, sustainability, maybe other projects that are not completely related to the idea of being more human-centric, but also to try to avoid humans in places where they could be problematic or they could have some problems by just repetitiveness. So, for example, this project was called AeroPaint, and it's a project that we developed with the help of Sofitech, a tier 1, that it's creating one specific piece of the airplane that it's called fan cowl. And the problem that they have, or the problem that in general airplanes have, it's that they required to create really large pieces. They have to paint those really large pieces, and this painter, it's extremely important because at some point it's just the final shield of the airplane before meeting the real air with the real conditions that they have to fly. And nowadays, humans are the ones that, with the use of simple lights, are required to test if those paints are good enough or are bad enough, and to decide if those pieces are good. So we created some tools in order to make the machines work directly and leave those repetitive works for the machines. Or, for example, the work related to piloting, that it's work that we develop a drone meant to perform inspection in high infrastructure. We are speaking about refineries, viaducts, bridges, tunnels. In general, we are speaking about places that are pretty high, and that if you need to set a human there, this human will be in danger just by the fact that it's pretty high. And those drones are nowadays capable of performing not only visual-based inspection. This visual-based inspection, it's also powered by artificial intelligence, and it's capable of detecting cracks and so on. And also it's capable of performing contact and perform measurements of the, for example, thickness of a pipe and so on and so forth. And finally, speaking about resilience and so on, we have also other projects related to machining and drilling. Moreover, exactly related to combining deep neuronal networks, combining long short-term memories systems in order to detect the status of a drilling tool, and if the machine has some problems while drilling. So the idea of that is that if you have to perform drilling 24 hours a day, 7 days a week, the system or the machine has to have somehow a self-knowledge of what's happening. And as humans, for example, if something bad is happening to our body, you get some feeling of pain, but the machine does not get this feeling. Instead of that, we charged our end effector directly with different sensors and with this deep learning technology in order to detect when those things are happening. Or, for example, also another project that we developed in the context of Clean Sky 2, where we were creating pretty big end effector that was meant to create the airplanes of the future, or to test how can we create the airplanes of the future. Directly, you can see on the right side of the screen the end effector taking a stringer and placing it on the belly of the aircraft. And the idea was to reduce drastically, thanks to the use of novel technology and novel materials, the weight of our aircrafts. A little bit about our facilities. We have an indoor localization testbed for testing our drones. We have several structural and material characterization tools. Like, for example, we have a press capable of making 4,000 tons of static and dynamic testing, also environmental testing, temperature, altitude, and so on. Our own airport for experimentation. If you need to perform experiments on an airport, we have an airport that has more than 30, well, more than half of the year has good weather to fly there. And also our multi-purpose robotic cell with 4 KUKA robots, 1 collaborative robot, and 2 AMR. Some pieces that we have sent to the space, couple of our customers, as you can see on the left, the main ones related to the aerospace, speaking about Airbus, Air Nova, Embraer, Fokker, Alestis, Airtech, and so on and so forth, but also big engineering companies, Capgemini, Iturri, Zeta Engineering, Acciona, also other companies that are not directly related to that, but that are useful in some other contexts, like, for example, Vodafone or Emacesa, that it's a local company for the water. Also, small and medium enterprises, something extremely important and that we are devoted to in our research center. So, Nespasa, CITD, Renshao, and also other research centers that also act as our partners in other research and development projects. And that's actually it from my side, Sylvia.